Okay, this is Mr. Herbson. The next standard is solving equations, okay? It's like finding the missing piece to a puzzle. Some number x plus 7 equals negative 11. My job is to find what number the x equals. Okay, so this is the way I would go about it. You got this x. I would put a coefficient of 1 in front of there. And then I'm going to put a box around it, the 1x. Now what's being added to the 1x or subtracted? In this case, a 7's being added. So what we do is we subtract 7. The opposite of adding 7 is to subtract it. So 7 minus 7 is going to be nothing. Okay? Now, if you're lifting weights, if you take 7 pounds off one side, you got to take it off the other side. So I subtract it from there. So I drop my equals. On this side we have 1x, but 1x means x, same thing. Then you can use your calculator. You take negative 11 minus 7. Here, I'll even show you on the calculator. Negative 11 minus 7. Negative 18. Okay, so x equals negative 18. Next one, 8 equals x minus 2. I need to find what the x equals. So it's smart, and you'll see why later on. It's smart to put a 1 in front of your x and put a box around it. And this time I have a 2 that's being subtracted. Well, the opposite of subtracting 2 is to add 2. Okay, so negative 2 plus 2 is 0. And then I add 2 to the other side. So that's going to be 10. And that's going to be x. Okay, so x equals 10. Okay, so far, so good. Okay, x equals, I put a 1 in front of that. And I have a subtraction of 2. So the opposite of subtracting 2 is to add 2. Okay. So negative 2 plus 2 cancels, and then I add 2 to the other side. Okay, negative 6 plus 2, again, it's not an 8, okay? It's negative 4. Okay, so negative 4. Next, negative 18 equals m plus 12. Now this time the letter's different, but that does not matter. Okay, so I put a 1 in front of my m, so it has a coefficient. And the opposite of adding 12 here, and by the way, the negative 18 you don't mess with. It's on the other side of the equals. Okay? You should not be trying to deal with this number right here. You should be trying to deal with the number that's on the same side of the equals as your letter. Okay? The 12. Opposite of plus 12 is to subtract 12. So that's going to be 0, and then we have to subtract 12 from the other side. So here's my equals, I drop it. Over here I have m, negative 18 minus 12. It's negative 30, but I'll even show you how you do it. Negative 30. Next problem, f plus 10 equals negative 10. So I'm finding what number f equals. So I put a 1 in front of the f and box it. So here's my equals. I have to get rid of this plus 10. So I minus 10 and minus 10. F. Now that is not 0. Okay, if you're at negative 10 on a number line, don't draw the number line, but if you're at negative 10 on a number line, here I'll even draw it, and you subtract 10, you ain't going towards 0. You're going further out this way. Negative 10 minus 10 is negative 20. So negative 20. Okay, the next problem, negative 1 equals x plus 5. So I'm finding out what the x is equal to. So I put the 1 in front. I put a box around it. So I have this 5 that's being added to that. Okay, so that's a number we got to get rid of. So the opposite of adding 5 is to minus 5. So minus 5 minus 5 will be 0. Minus 5 on the other side. Okay, so on this side I got -1 minus 5, that's going to be -6, and over here I just have x. -6 is our answer. Next problem, I'm finding what the x is equal to, so I put the 1x. I have a -14 out here, so the opposite is to add 14, so I add 14. -14 plus 14 is 0. Then I add 14 on the other side. So 8 plus 14 is 22, and then over here we have x. 1x means the same thing as x. Now you're like, why are you always putting a 1? You'll see why here when I get to the other page. It's smart to box up the letter and the coefficient in front. Okay. So we have this -3 outside of here. What's the opposite of -3? I think it's +3. So I put a +3 and a +3. So over here I have -2 plus 3 is 1, and over here we got x. So that's 1. Okay. Next page. 3x equals -48. I don't put a 1 there because we already have a 3. I don't have anything outside the box on this side of the equals. The equals is right there. I don't have anything outside the box. Okay, so I'm not going to add or subtract here. If we do that, that's wrong. When I have a number in front of the letter, and that number is not a 1, and it's not a 1, we underline both sides, because that means we are going to divide by this very number right here. So 3 and 3. Now 3 divided by 3 is 1, but that'd be 1x. That's the same as x. -48 divided by 3. -16. (98) equals -7 times x. So I'm finding what x equals. And now I don't put a 1 because there's a -7, so I'll box that up. Okay, -98 equals -7x. -7 times x. Now there's nothing outside the x that's being added or subtracted. So if that's not a 1, we need to underline both sides, and we divide by the very same number that's in front of the x, in this instance -7. No, you don't divide by +7, you divide by the same number with the same sign. Drop the equals. Over here we got -98 divided by -7. We get 14. And over here, -7 divided by -7 is 1. 1x is the same as x. So, okay, -4.4 equals -4x. Okay, we won't put a 1 there because it already has a -4. Okay, and there's nothing outside that box on this side of the equals. Okay, because here's my equals, nothing outside the box. So no adding or subtracting is necessary. We underline both sides and we'll divide by the -4. So over here, -4.4 divided by -4 is 1.1. And over here, -4 divided by -4 is 1, but then since I have the x, I'm just going to put x. Okay, so 1.1. 2.8c equals 42. Again, can't put a 1. We have a different number at 2.8c. Okay. Nothing I need to add or subtract outside this box. I know this is outside the box, but that's on the other side of the equals. Okay, that's fine where it's at. So this 2.8, need to underline, put a 2.8. Okay, so 2.8 divided by 2.8 is 1, and that's going to be C. Then I take 4.2 divided by 2.8, and that is 1.5. C is 1.5. Negative 3x equals 108. So if I want x equals, again, we got a negative 3. We can't fit a 1 in there because there's a negative 3 there. Box it up. Okay, so there's nothing outside the box, but I don't want that negative 3 there. I want a 1 there instead. So if I need to replace a number in front of the x with a 1x, I need to underline both sides, and I will be dividing by whatever number's in front of my variable, my variable's coefficient. So negative 3, negative 3. So that is going to be x, because that's 1x. 108 divided by negative 3 is negative 36. Okay, 4x equals 27, so that's what x equals. Okay, I can't put a 1 there, there's a 4 there. Okay, nothing else but the 4x. So that 4, I think we need to change that to a 1. I do that by underlining both sides and dividing by that. So 4 divided by 4 is 1, but since I have x there, it's 1x, or x. And then I take 27 divided by 4, you get a decimal, 6.75. Negative 5x equals 15. That means negative 5 times x, so we're going to box that up. Again, nothing outside the box to worry about. I mean, again, I know 15's outside the box, but the reason I don't worry about 15 is because it's on the other side of the equals. So I underline both sides, and I will be negative 5. Negative 5 divided by negative 5 is 1, but that'll be 1x, or x. And then 15 divided by negative 5 is negative 3. Negative 2x equals negative 14. X equals. Again, we don't have a 1. We have a negative 2 as the coefficient. Nothing else going on outside. Okay, that's not going on outside, dude. That's on the other side of the equals. Negative 2. I know that negative 2 divided by itself is always 1, but that'll be just 1x, which is x. And then negative 14 divided by negative 2 is 7. Okay, next page. X divided by 6 equals 8. Remember, the underline means divide. These look a little different here. Smells a little different. So now I can fit a 1 there. Coefficient's 1. So I don't need to divide. But when I box up, I want to get the whole fraction. If the x has something under it, we want to get the whole fraction in there. Now the question, there's nothing going on outside your box, so don't add, don't subtract, neither one. We have a 1 in front of the x, okay? So I don't divide either. How do I get rid of 6? What do I do about that? When you have a number in the bottom you want out of there, you do the opposite of divide, which is to multiply. So put dots, and we're going to multiply by 6. Here's why I multiply by 6. Let's say this number is 50. Okay? If I take 50 times 6 and divide it by 6, I get 50. So pretty much it's like that cancels itself out. So whatever number that is, these will cancel out and I'll have x. And then 8 times 6 is 48. $16 equals x divided by 8, so x equals 1, but we need to get the whole thing, okay? Again, nothing's going on outside. I need to add or subtract. It's this 8 here, man. I'm not going to divide. That'd be if the 8 was here, I'd divide. No, I multiply. So I times and times. And this is the number I want out of there, so that's what I times each side by. That cancels and we have x. Whenever I multiply and divide by the same number, it cancels. Then 8 times 16 is 128. Okay, next problem, x equals. Got a 1x, but there's a -3 under it. It's like you have a coefficient of -1/3. Nothing going on outside the box, so there's no adding or subtracting to do. If you add or subtract anything, you're doing the wrong thing. It's that -3. I mean, I'm good with the 1. Okay, we want the 1 in front of the x, but I don't want the -3. So I times by the -3. Over here on the equals, -3 times -9 is 27. Over here, these cancel and we have x. 27. This time we're solving for n. By the way, up here that'd be 128. So we have a 1, that's good, okay? But it's 1/10, okay? I should not be adding or subtracting anything. There's nothing here, nothing there, okay? Adding and subtracting is for things outside your box, nothing outside the box. I'm good with the 1, I'm not good with the 10. We need to get that 10 out of the denominator. So 10, 10. Cancels, that's n. -22 times 10, -220. Okay, next problem. 3/5 n equals 12. Okay, I have a way I like to do this. There are other ways, but I have my way. I'm solving for n. If you don't like my way, you can come back and talk to me. I'm not going to yell at you. I'm just going to show you another way you can do it. There's my n. There's a 3 in front of it, so don't put a 1 there. You can't fit a 1 there. So that's my whole n term. Nothing going on here outside of my box, okay? But this time I got 2 problems. I got a 5 on the bottom, and I've got a 3 in front. What you should take care of first is that number beneath the line. So when you do that, we multiply. So 5 and 5, knowing that the times and divide by 5 cancel. But over here I don't have n, it's 3n still. Then 12 times 5 is 60. Now let's deal with the 3 that's connected to the front. We underline both sides, means I'm dividing by 3. So over here we got n, or 1n. 60 divided by 3 is 20. Again, really, we need to multiply by that number, but then after that we divide by that number. The reason I didn't do that here is because I had the 1 in front. Okay, if I have a 1 in front, that's good. I don't have to, that's less work. Okay, -4 equals 2/3 b. Okay, now there's nothing going on outside, but I have a 3 and a 2 I need to deal with inside. So let's deal with the 3 first. That's beneath a line, so I times both sides by that 3. Over here, 3 times -4 is -12, and all that happens here is that and that go away. So I have 2b. But because it's a 2b and not a 1b, we have to underline both sides and divide by 2. -12 divided by 2 is -6. And over here we got b. b equals -6. Next one, x equals 5/8 x. Again, your coefficient is 5/8. So put the coefficient and the letter in a box. There's nothing outside. Okay. So first we deal with the 8. Times both sides by the 8. Okay. The times 8 and the divide by 8 are out. And over here we have 5x. Over here I take negative 15 times 8, negative 120. Okay, because I have a 5 connected to the front, I need to deal with the 5. I'm going to need to underline both sides. That means I'm dividing both sides by the 5. 5 divided by 5 is 1, so that's x. Negative 120 divided by 5 is negative 24. Okay, the last one's kind of funky. 1/4 x equals 2/5. Trying to find out what the x equals. Okay, so there's my x. 1/4 is my coefficient. I'm good with having a 1 on top. That's good, but we got to get this 4 off the bottom. So I'm going to be timesing by 4. Over here, the times 4 and divide by 4 cancel, and that gives me 1x. Well, that's good that I have a 1, because now I can just call it x. If that would have been like a 2, I would have had to put 2x and then divide by 2, but it wasn't. Now you're like, how do I multiply this over here? All you do is take 2 times 4. Okay, 2 times 4 is 8. And then 5 goes in the denominator, 8/5. The boxes help, okay? You get the problems all wrong because you don't use boxes, well, that's on you, okay? I'm trying to give you a strategy that works. If you don't follow it, well, you know, and you still get the answers wrong, well, I'm trying. Okay, on a quiz show, a contestant was penalized 250 points for an incorrect answer, leaving the contestants with 1,050 points. How many points did the contestant have before the penalty? I'm finding the points here. That's the answer to the problem. That's why I have it underlined. That's the only important unit in the problem. So what I do at the 250 and the 1,050, you want to put the top bigger number here, is either add or subtract those. Since you only have one significant unit, it's either adding or subtracting. Okay, so they had 1,050 points, but that's after they had 250 points taken away. They want to know how much they had before. Now you got to use some common sense. You're not going to subtract, you're going to add. You got to use some kind of common sense logic there. 1,050 plus 250 is 1,300. Okay, at a party of 102 people, 17 pounds of baked potatoes are served. Find the people each pound of baked potatoes served. Okay. Now here's the answer: is people each pound. So that means people per pound. Each means per. It means the same thing. Now this, you got to take your 2 units and divide them. You take your 102 people. It's because you got to divide the people by the 17. 102 divided by 17 is 6. Over the last 220 years, the U.S. Constitution had 27 amendments. How many amendments per year were made? Okay, so again, it's the answer is amendments per year. It helps if you put the label on your answer down here. It means I got to divide. I got to take the number of amendments, 27, divided by the number of years, 220. It's got to be divided in order too. It's top divided by bottom. It's going to be 0.12. That's okay. Go round to the nearest hundredth. Next page. Jeremy mowed several lawns to earn money for camp. After he paid $17 for gas, he had $75 left over to pay towards camp. How much money did he have before paying for gas? The answer is money. That's the only important unit in the problem, dude. So all this is either an adding problem or a subtracting problem when you have only one important unit. Okay, after he paid $17 for gas, he had $75 left over. It wants to know how much money he had before he paid for the gas. Well, I would have to add this back on. 75 plus 17 is $92. Okay, Susan's cell phone plan allows for 850 minutes in a month with no additional charge. She has 188 minutes left for this month. How many minutes has she already used? Again, minutes is the only is a unit, and all I have is minutes for units. So I just take the 850 and 188 and just do some simple math. Okay, so that's how much your plan allows. She has this much left. It wants to know how much she's already used. Well, you're not going to add them. Okay, you can't use more minutes than what you started with. So you're going to subtract them. 850 minus 188, 662. Okay, and then our last one. Community center serving free meal to senior citizens. The center plans to feed 700 people in 4 hours. How many people per hour does the center plan on serving? People per hour is my answer. That means I just take the people, 700, divided by the number of hours, 4. 700 divided by 4 is 175. Okay. You don't need to use your book. I got the problems written. So you see a problem like that, you need to put a 1 in front of the x. You got to get the 3 out of there. Okay. It's a positive 3. The opposite would be negative 3, which means we subtract 3. All this stuff here is adding or subtracting. Next page, let me take this problem. You don't put a 1 there, there's a 5 there, okay? So there's nothing going on outside the box. You just need to underline both sides, meaning you're dividing by 5. Okay? Put the 1 there, it's the whole fraction. No adding or subtracting, nothing outside. Times negative 5. Times negative 5. Okay, and then this one, 2/3. You got to times by 3 on both sides, and then divide each side by 2. Thank you.